Okay, so we're looking at applications of differentiation. Let's see if we can make that little. Okay, so starting with tangents and normals. Okay, I'm just trying to think. Yeah, so we did look at normals last year. I remember what a normal is. We're thinking about tangents and normals. Bianca? Yeah, yep. So if we have a curve, okay, and then draw a line, okay, so that's our tangent, okay, tangent at that point where it just touches the curve. And then if we have a line that passes through that same point but is at right angles, then that is the normal. Okay, so we're going to use calculus, use differentiation as a means of finding the gradient of a tangent and a normal, which we can then find the equation of the tangent or the normal. Okay. So remember, differentiation, or to find the derivative, okay, the derivative of a function is effectively the rule or the expression that will give us the gradient of the curve. Okay, so this is a parabola. We'll be able to find the derivative of that parabola. Say if it was y equals x squared, then the derivative is 2x. We can use that to find the gradient of this curve at any particular point. Okay, so if we know the x coordinate at a particular point, then we can find the gradient at that point by substituting that x coordinate into the derivative. Okay, that gives us the gradient, which then we can use to find the equation of the tangent or the normal. Okay, so we think of an example. Okay, find the equation of tangent to y equals x. That's right. X cubed minus 2x plus 3 at the point 1, 2. Okay, so if we're wanting to find the equation of a line, we need effectively two bits of information. We need the gradient, and we just need a point on that line. Okay, so here we've got the point. Okay, so we just need to be able to find the gradient first. So our first step is to find dy dx. Okay, so the derivative by differentiating x cubed minus 2x plus 3 will be 3x squared minus 2. Okay, so that is our gradient function. At our point 1, 2, dy dx will be 3 times 1 squared minus 2. So we just need to substitute that x value. So the y value has no impact on the gradient because our gradient function, our derivative, is just in terms of x. So we just need our x coordinate. Okay, then we can work that out, so that's going to equal 1, which means that the gradient m of our tangent will be equal to 1 at that particular point. Okay, so we've got our gradient. We just need to now find the equation of the straight line, which is the tangent. So a couple of ways: you can just use y equals mx plus c and substitute your x and y coordinate in order to find c, or you can use y minus y1 equals m inside of x minus x1. And so x1 and y1 corresponds to the point 1, 2. So that y minus 2 equals 1 inside of x minus 1. And then just expand and rearrange it. Okay, so same sort of idea here, except we're wanting to find the tangent and the normal. Different curve, so it's a log graph. So first step is to find the derivative. Okay, so if y equals 3 log 2x, then dy dx will be 3 over x, because it'll be 3 times the derivative of our log function, and the derivative of log 2x is just 1 over x. So gradient of our tangent, which I'll just write as mt, will be equal to 3 over 1. Okay, so we just need to substitute our x coordinate into our derivative. How do we find the gradient of the normal? Yeah, okay, so perpendicular lines, their gradients are negative reciprocals of each other, or alternatively, when you multiply them together, they'll equal -1. So the gradient of the normal then will be -1 over 3. Now the other thing we need to do is we've only got an x coordinate, so we need to find the y coordinate in order to get our equation of either the tangent or the normal. So if x equals 1, then y will equal, we go back to our original equation, 3 log 2. Okay, so we're just using the 0.13 log 2, and so it's not necessarily going to be a nice looking equation, Okay, we're just going to use the exact values that are there for our y coordinate. So yeah, but still writing in that form, y equals mx plus c. And so we have y equals 3x minus 3 plus 3 log 2. So, which basically means that our y-intercept would be negative 3 plus 3 log 2. Or you could write it as 3 log 2 minus 3. Well, that doesn't really matter. Okay, so that's our tangent. The normal would be done in a similar way, so we're just using a different, obviously the different gradient. Okay, I was just seeing whether there would be a different type of question to do with an example, but that's okay. We'll leave it at that. What I will get you to do, we've got a couple of options here, but we might change it up a little bit. And exercise 8A in the yellow. But if you're really opposed to getting that textbook, you could use this one, and it actually is the same exercise. Exercise 8A in either of those is fine.